Okay, the next unit that we're getting into is the exponential and logarithmic unit. So we're going to do the exponential graphs today. All right, and then I'll teach you what a logarithm is, and then we'll do the logarithmic graphs. But today's just exponential. So for an exponential function, what makes it exponential is the variable is the exponent. So you have something to the x power. And that's why it's exponential. The variable is the exponent. These ones look like a swoop. I always just go like this when I'm talking about them, like just like a. All right, so they have a horizontal asymptote, not a vertical asymptote. They don't have both, only horizontal. And so it would look like this: f of x equals, and we call the base a, it is just picked a letter of the alphabet, a to the x power, but that would be a value. It would be like 2 to the x, or 10 to the x, or 3 to the x. Do you get what I'm saying? Like there would be some kind of number there. And that would be exponential growth. Have you ever heard such and such grows exponentially? Like you've heard that said before? What that means is grows really, really fast. Kind of like COVID cases. You know what I'm saying? Like grows exponentially. Now, if it's written like this, a to the negative x, or that would mean the same thing as the fraction 1 over a to the x. And we're going to have a big conversation about negative exponents in just a second to make sure that we all have a grasp on that. Okay, those mean the same thing. That would be what's called exponential decay. You may have heard of that in chemistry class, like you have an element and it decays over time and has like a half-life. Do you know what I'm talking about? Like, anyway, there's less of it than there was before. One goes up and one goes down, essentially, is all that there is to that. Right? Exponential growth, exponential decay. So we're going to practice stating the transformations. This is exactly what we did back in unit 1. There's the only thing that you really need to worry about. The base number, which would be this, whatever's being taken to the power, the base number does not cause a transformation. It's just there. You have to have something to the x power. So like in letter A, 5 is the base. That doesn't do anything transformational wise. In letter B, this 3 is not going to cause a transformation. And in letter C, this 1/7 is not going to cause a transformation. Those numbers are just simply there as the base number, right? Everything else is going to cause a transformation. So in letter A, you know I'm going to tell you the answer, but I want to see what you got. How did this graph get shifted? Good, right 3. Remember, left and right is kind of backwards. So right 3 and what else? Up 8. Perfect. What about letter B? There's 2 things for that one. Down 4. Oh, and there is a reflection. I know you're like, is it X or is it Y? You got a 50-50 shot. Anyone want to give it a guess? Y, good. If the negative is inside the function, it's over the y-axis. If it's outside the function, it's over the x-axis. So quick shot at redemption here. Letter C, this negative would reflect over x. Good. Okay. And then there's a couple more things for that one. We multiplied it by a 4 out front. I'll give you a hint. It's a vertical something or other. Good, perfect. Vertical stretched by 4, so it's 4 times as tall. And then that +9 is inside. That's kind of backwards. It would be left 9. Perfect. So just remember the base doesn't cause a transformation. Now we're going to real quick take a detour from exponential functions for a second and just talk about exponents. You have to understand the algebra of exponents in order to do exponential functions. I could skip this and be like, you should all know it, but we're going to take a minute and just go over it. Let's write out the first 12 perfect squares. All right. Being squared is something that we see a lot, right? 1 squared. 1, good. 2 squared. 4, 3 squared is 9. Could you continue the list without me? Okay, I don't want to put you all to sleep, but just go ahead and write out the first 12. And if you know them further, that's awesome. I have some people that can rattle them off like for a while further. If you know at least those ones, you'll be good. Now, I don't have you go as far with the cubes because when you take a number to the third, the numbers get bigger a whole lot faster. So it gets out of hand really quickly. But let's do the first 5 perfect cubes. And if you know them further, that's awesome. But let's at least know that. 1 cubed is 1, 2 cubed, 8, good, 3 cubed, 27, 4 cubed. Now you have to be careful with that one because it's on both lists. 8 squared is 64 and 4 cubed is 64. So just be careful with that. And then 5 cubed, 125, right? Now, to the 4th and to the 5th, again, the numbers get outrageous really quick. The only ones I would ask you about would be 2 to the 4th or 2 to the 5th, because or I guess 1 to the 4th, 1. But let's talk about 2 really quick. 2 to the 4th. Those are the only ones you would see to a higher power is 2. That'd be 2 times 2 times 2 times 2. So good, that would be 16. And then 2 to the 5th, you would just times by 2 again, would be 32. You need to just plain know those ones. Like you need to just have those in your back pocket. I think a lot of you know most of them already. Whenever we did the binomial theorem, do you remember when we expanded those? Like we did a lot with these, so I think, remember those. All right, let's talk about the negative exponents. When you have a negative exponent, it means you reciprocate. Actually, let's write that down. Negative exponent. You are going to reciprocate. It doesn't make the answer negative. It means you flip it over. But humor me. I just want to take a minute and go over these because if I just expect everyone knows them, then when we get to a problem with a negative exponent, everyone freezes up like deer in the headlights, right? Letter A, you would just do 3 squared and then flip it. So what's 3 squared? 9. Reciprocate it, it would be 1/9. That's all there is to it, but I realize it looks scary because negatives are scary, right? 4 cubed is 64, we just did that. Reciprocate it, 1/64th, good. Anyone want to give this one a shot? Good, 1/49. This one, I would flip the 1/5 first, that would just be 5. The negative exponent reciprocates, so that would just be 5 to the 3rd is 125. And then how about this last one? 81, good. It would be 9 squared would give you 81. Do we feel okay with negative exponents? Maybe not 100%, but like we at least went over, right? Now here are the fraction exponents. I know negatives and fractions are the 2 most scary things, so that's why I wanted to take a minute and go over them. When you see a fraction exponent, that is a root. So 1/2 would be a square root, 1/3 would be a cube root, 1/4 would be a 4th root. So this means square root of 36, so that would just be 6. How about 49 to the 1/2? Be 7, it's square root of 49. This would be cube root of 8. What would that be? Good, that would be 2. Ooh, this one has a 2/3. All right, if it was a 1/3, that would be a cube root. So you would have cube root of 8. But then this 2 means that you're gonna square that. So the denominator tells you what kind of root it is. It would be a cube root, but then to the 2nd power. We just did cube root of 8. That's 2 squared would be 4 for that. And then this one would be a 4th root of 16. So that's what to the 4th power would give you 16. And that would be 2. That's the only, like, if you see a 4th root or a 5th root, basically it's going to be 2 because that's the only one I'm going to ask you. Does that make sense? Like, all right, fill in the table for this function, -2 to the x. I'm going to start with the positive numbers first because those are going to be a little bit easier. If we plug in 3, you would have -2 to the 3rd. What is that going to give us? I mean, -2 times -2 times -2. That would be -8. Perfect. If you plug in 2, you would have -2 squared. Good, +4, perfect. -2 to the first would just be -2. Anything to the first is just going to be itself. Now let's have a conversation about this one. We've talked about it before, but in this unit, it's going to be huge because we're doing exponential functions. Any number to the 0 power is 1. Good. Put like stars next to that if you think you're going to forget, because you really need to know that. All right, -2 to the negative first. I know that the number is negative and the exponent is negative, so that's like double whammy there. The negative exponent means that you reciprocate it. So it is going to be -1/2. It means that you flip it over. -2 to the -2. Well, -2 squared would be 4. You're just going to flip it over. So 1/4. And then -2 to the -3rd. Good, you guys got it. And do you see, like, it's not symmetry, but do you see like the pattern on each side? Oh, hold on, I need to say something about this. What do you notice is going on with these values? -1/8, +1/4, -1/2, +1. Like, what do you notice? They alternate. You're not gonna get a graph out of that. This is what's called oscillating behavior. You have positive, negative, positive. Can you imagine if you plotted those points and then tried to connect them? It would be like this. You following me on that? It would look like, you know, one of those heartbeat monitors, except like your heart spazzed out and it went crazy, okay? You cannot have a negative base. And this is the reason why. You will have positive, negative, and you can't get a graph out of that. So later on, when we talk about you can't have a negative base, try to remember that this is the reason why. Because like a week later, when I'm like, hey, you can't have a negative base, everyone just kind of stares at me like, why not? And I'm like, we did talk about that. So like, just try to keep that in there. I will explain it again if I have to, but anyway, that's the reason why. You cannot have a negative base. So let's try actually doing a couple of graphs. These are my favorite ones. Like out of all the parent functions, I like exponential the best. It's a swoop. You know, it's just fun. They're easy. They're like not too bad. All right. So first, let's try and get the horizontal asymptote in there. You want to dot that in first. There will be no vertical asymptote. That's just going to be none. It only has horizontal. This is why I went over the transformations. Typically, the asymptote is at 0. So if your graph shifted up or down, that's going to change where it is. Did this graph move up or down? It went down 4. Good. So instead of being at 0, you're going to go down 4 and dot that in. And so it is y equals -4. Do that first. Remember when we did the rational graphs and we put the asymptotes in first? That's like your framework. So do that first, then you've got that. And then we'll go back and plot some points. So let's make a little XY table, decide what we want to plug in. Now, we talked about how 0 is usually the easiest thing to plug in, and that's right, but you need to figure out what X value is going to make your exponent 0. Like you want the exponent to be 0. So you don't want to necessarily plug in 0 first. What would you want to plug in first for this one? Yeah, good. Thank you for coming with me on that, because sometimes you could start at 0, and if the graph got shifted somewhere else, like 0 is not actually a very good option. So let's plug in -1. Here we go. -1 + 1 is 0. Anything to the 0 power, 1 - 4, -3. Now I'd like a few more numbers. We started with -1, so let's pick something near -1, which would be 0. Let's do 0 next. 0 + 1, 1. 2 to the 1, 2 to the first. Be 2 - 4, -2. Don't go to sleep on me. It's not hard, it's just arithmetic. All right, what's the next number you'd want to plug in? We did -1, we did 0, 1. 1 + 1, 2. 2 squared, 4 - 4, 0. Go ahead and plot those. It will be a swoop. And then once you have the graph, listing out all the characteristics is not too bad because you have a visual of what you're looking at. So what's your domain going to be? Left to right? Yeah, everything, right? Someone might have said that. I didn't hear you back there. Everything. That's going to be the answer. That will be the domain for every exponential. It's just all reals. Range will not be, though. Sweep downwards to upwards. It would be from where to where? Good. Bracket or parenthesis? Oh, good. Why parenthesis? Good. That's not a point. It's never going to touch. It'll get closer and closer, but it won't actually get there. All right, x-intercept. Where does it touch the x-axis? 1, 0. Y-intercept, 0, -2. See, this is the easy part. I like this. You just look at the graph and answer it. Now, it will either be increasing or decreasing. It's not going to turn around. Is this graph going up or going down? Going up for all the time. Decreasing is none. It is exponential growth. It's growing. And then your end behavior. It's going to be limit as x goes to -infinity of the function. Limit as x goes to positive infinity of the function. Just go ahead and set it up, and then we'll look at the two ends. One end will go towards the asymptote. The other will either go up or down. So where is our left end headed? -4. It won't ever actually get there. That's where it's going. And then the right end goes up. So positive infinity. All right, let's try one more and then I'll give you a break, okay? The first thing you want to do is the asymptote. It's typically at 0 unless it's shifted up or down. So where did this one shift? Up 3, good, go up 3, dot that in, and then you can write it on the line over here. And then you want to get some points. So make yourself a little table. You want to start with 0, but it's not that x is 0. You want to plug in an x value that will make the exponent 0. That's like where the center is. So what x number do we want to plug in for this one? Good, 2, perfect. 2 minus 2 would be 0. Anything to the 0 power is 1. Except it's going to be negative. So -1 plus 3 is 2. All right, what do you want to try next? 1. And if we pick a number that doesn't turn out pleasant, what will we do? Panic? No, just pick a different number. Like, just pick a different number, all right? 1 minus 2. -1, it's fine that it's a negative exponent. That just means you reciprocate. So instead of a 1/3, 3. 3 to the first is 3. It's negative, so -3 plus 3 is 0. And then let's do one more. What else do you want to try? Let's try 0. 0 minus 2 would be -2. That means that you flip it. So instead of 1/3, it's 3. Squared would be 9, except it's -9 plus 3, -6. Can I just show you, because I know someone out there is thinking, well, why didn't we do 3? Let's try and plug in 3. You can. I'd recommend against it, though. Watch what happens. 3 minus 2 is 1. 1/3 to the first would be 1/3, and then you'd make it negative, so you'd have a -3 plus 3. It's not undoable, it's just not very fun. So like if you get a weird fraction like that, just go the other direction. All right, go ahead and plot those. You will end up with a swoop. This one got reflected, that's why it's down there. And then once you have that, getting the list of characteristics isn't so bad because you just use that to answer all the questions. Domain will be everything. In fact, you could answer that like before you even start any of the rest of that. Like that's going to be the answer. All right, how about the range for this one? Downwards to upwards. Good, perfect. Negative infinity to 3, parenthesis, x-intercept is 1, 0, y-intercept 0, -6. Reading left to right, is this increasing or decreasing? Increasing, good. Will there ever be any that decrease? Yeah, like it just didn't happen to turn out that way, but like what if it looks like this? You see what I'm saying? Like they could be going downwards. I don't want you to get the impression that that never happens, right? And then go ahead and set up the end behavior. Limit as x goes to negative infinity of the function. Limit as x goes to positive infinity of the function. So where is the left arrow going? Down, so negative infinity, and then the right arrow goes to the asymptote, which is 3. So these next couple problems we're going to do involve compound interest. This is like you put money in the bank and you can get interest on it. Now the examples I'm going to use like sort of realistic, like bigger numbers so that we get like an actual answer. You realize in real life, your interest rate will be like 0.001%. Like you'll make 3 cents interest per year. You understand what I'm saying? Like in real life, it won't give you that. But when you owe money, like what you're about to have if you go to college, like your student loans, that interest rate will be huge because they want to take your money. Real understanding like the real life aspect of this. Okay. I'm going to give you this formula. It's going to scare you at first, then I'm going to explain what it all means and you're all going to calm down. Every time I do this, it's like, oh my gosh, what is that? But then when I explain what it is, it's always not so bad, right? So here's your formula. A equals P parenthesis 1 plus R over N to the power N times T. I know that is like the alphabet threw up on your paper. I'm going to tell you what it all means. A is the amount that you're looking for. That's like your answer. A is the answer. That's what you're going to be asked for. So you kind of don't need to worry about that. That's just going to be the answer. P is the principal. That's how much money you start with. So that's like the amount that you put in the bank. Or like if you're talking about owing money, that's like the amount that you owe. R is the interest rate. And you have to write it as a decimal. So for example, if it was 2%, how would you write 2% as a decimal? 0.02, it's 2 out of 100, okay? T is time. So that's how many years you want to let your money sit in the bank. That's like how long you want to let it cook, all right? And then N is the number of times that the interest is compounded. What that means is when you compound the interest is you take that interest and roll it into the total. So like say you made $100 of interest. Again, that wouldn't happen, but like you take that $100, add it into the total, and then now you're doing a percentage of a larger number. Does that make sense? Like you're rolling the interest into the total. The more times it's compounded, the better off you're going to be with making more money, all right? So if your money is compounded yearly, then N is 1. You compound 1 time per year. Oh, I'm sorry, not yearly. It's called annually. I'm sorry. Annually. That means once per year. N would be 1 for that. Semi-annually means that N is 2. You compound twice per year. Quarterly, what does that sound like that means? N would be what? Good, 4 if you compound quarterly. And then monthly means N would be 12, good. So it kind of is what it sounds like, but that's what N is. It's the number of times that you roll the interest over into the total. I get that that was a lot. I understand there's a lot of like things to plug into, but it is just a formula. We're going to plug it all in and type it in the calculator and get our answer for our dollars cash money. All right. So number 8, and all that stuff's going to be handed to you. Like none of it's going to be missing. I'm not going to give you an undoable problem, right? Find the amount present in an account. So you're going to have A equals a principal of 700. So 700 is P. That's the first thing there. And then parenthesis 1 plus, and then it's R over N. All right, here's your interest rate, 3.5%. Again, you have to write it in decimal form though. So that would be 0.035. You scoot the decimal point twice because it's 100%. You move it twice for the hundreds place. All right, over N, let's see. How many times does it say it's compounded? Quarterly, good. So N is 4. Close the parenthesis. And then it's to the power N times T. So we just said N was 4. T is the number of years. So how long are we leaving the money in there? 5 years. All right, put a $sign. We're all going to type this in the calculator together. Have we had the conversation about how many decimal points to do in this class? I can't remember if you've talked about that or not. For AP calculus, you need 3 decimal points all the time. So I like to try and encourage you guys to always do 3 decimal points just to get you ready for that, because I know a lot of you will go on to calculus next year. I know not everybody, but some of you will. For money, I'll take 2, but I'll be happier if you put 3 just because I want you to get used to that, okay? So here's how this is gonna get typed. 700, parenthesis, 1 plus. All right, how do I get the fraction bar on here? Do you remember how to do the fraction bar? No, that's okay. It is alpha y equals. Alpha y equals. We'll give you that fraction bar. N over D means numerator over denominator. Are we all still okay? All right, 0.035. If you forget to change the percentage to a decimal and you put 3.5, you will catch it because you will get like $1 billion. Like it'll turn out to some astronomically large number. All right, over 4, close the parenthesis, to the power, 4 times 5 is 20. So I'm just gonna go ahead and type 20, and then that is your answer. You wanna check, does that make sense? All right, hey guys, if you start with $700 and you earn some interest, does $800 and some dollars kind of make sense? Yeah, if you got like $400,000, you would hopefully be like, oh, I hit a wrong button there, okay? So this would be 833.237. For AP calculus, you don't have to round. You can do what's called truncating, which means you just take the first 3 decimal points. So that's what I am in the habit of doing. I just take the first 3 decimal points, all right? I would take 0.237. I would accept 0.238, and I would accept 0.24 if you wanted to round to 2 decimal points. Those are all the answers I would accept, okay? So however you choose to do that is fine, but this is what I'm gonna write. Also, doing the 3rd decimal place for money does kind of make sense. Do you guys ever notice on the gas pump that they have that extra little 9? Because they're charging you that plus 9/10 of a penny. So it's actually like a penny higher really than what they say it is. All right, number 9, find the amount present in an account. So A equals, principal is $1,000, parenthesis, 1 plus 10% interest rate. That would never happen, all right? But it would be 0.10 over N. All right, read through. What is N gonna be for this one? 2, good. Semi-annually means 2. And then to the power 2 times the amount of time, which they said was 3 years. Everybody go ahead and type it in. You should get a number a bit bigger than 1,000. You start with $1,000 and then you earn some interest. It should be like a bit over 1,000. So just make sure your answer makes sense. What'd y'all end up with? Yeah, now I would accept 0.095. That's what I'm gonna write. I just always take the first 3. 0.095. I would accept 0.096, and I would accept 0.10 if you wanted to just do 2 decimal points. But I just always do 3, and I just take the first 3. I think that's the easiest way to do that. Again, I'm just trying to gear you for next week. Now, what happens if your interest is compounded continuously, which means like every second of the day? Again, the more times you compound, the better it is because you make more money. So we're going to do limit as n goes to infinity of this. We want to compound continuously, which means you would want n to be infinite. So we're going to look at this part of the formula. We're going to have to put 1 in for r to make this work, though. So we're going to put 1 for r. So it would be 1 plus 1 over n to the nth power. I'm going to show you what happens with this on the calculator. I'd like for you to just watch, all right, just so you can see visually. Here's what I'm going to do. I'm going to go to y equals, clear it out. It's already clear. And I'm going to type this in. Now I'm going to have to use x because that's the variable key. And this is another one of those things. I always go through this explanation and then a week later, everyone's like, where'd that come from? I'm going through it right now, so try to pay attention. I know we're all tired, but all right. We've got 1 plus 1 over x to the x power. Again, I just use x's instead of n's. I'm going to go to the table. And look what happens as I scroll on. Do you see how it's 2.5 and then 2.6? And then it's kind of going up a little bit, but not much. All right. What I want to do is take it out to infinity, right? I want like really, really, really huge numbers. So I'm going to go to my table set. I'm going to start it at 0, but instead of counting by 1, let's count by something bigger. What do you want to count by? Because instead of going 1, 2, 3, we can count by something larger, like a larger increment. 10? Let's try 10. Now it's going to go 10, 20, 30, 40, all right? I want to get it to the point where it's like leveling off somewhere. Do you see that? Let's count by something even bigger. I'm going to start it back at 0. Instead of 10, what do you want to try? 100. I want to get it to the point where all the numbers are the same. Like it's actually stopped increasing. And it's still going up. Let's try 1,000. This should be good. There we go. We found it. Do you see how it's not changing now? That's the number where this is leveling off. It is 2.718. ... It's an irrational number. It keeps going forever and ever. This number is called E. You know how pi is 3.1415 ... forever and ever? We define that to be pi. This is the number E. Letting that sink in. Is that okay with everybody? Like it is a value, but we call it E. This is your special number where this levels off as you take n to infinity. So if you are compounding continuously, your amount will equal your principal. And then this magical number E to the power R times T. It's your interest rate times the time. No one ever has a problem remembering this formula because it spells PERT. So if it says compounding continuously, this is the formula that you use. 10 and 11 are the exact same problems that we did here, except we're going to compound continuously, which means you're going to make slightly more money because you're compounding continuously. All right, so this will be A equals 700 E, which again is a number, to the power R times T. Our interest rate 3.5%. That would be 0.035 times the time, which is 5 years. I'm going to show you how to type this, okay? Again, you got to listen because otherwise you'll forget where the buttons are. All right, so everyone type 700. E is right here. I know there's kind of a glare on there, I'm sorry, but do you see like kind of right next to the 4, there's a button that says LN and above it, it says E. So since it's above that button, how do you get that? Second, hit second LN and it will put E on the calculator screen. And notice it already put the exponent for you, which is nice, right? And then you're gonna put 0.035 times 5. And that will give you your answer. So it is second LN. I got 833.872. Is that a consensus? All right, compare that to number 8. Do you see how it's slightly more? Now, if the interest rate was a lot higher, you would see a bigger difference. Or if it was a lot more than 5 years, you would see a larger difference. But very slightly more because you're compounding continuously. All right, and then for number 11, principal is 1,000. E to the power, interest rate is 0.10, and then times 3 years. And again, the reason we're using PERT is it says continuously. So go ahead and try and type that one. Again, to get E on there, it's second ln. I got 1,349.858. I would also accept 0.86, and I would also accept 0.859. I would accept any one of those. Now compare. Do you see how that's slightly more than this one? It was a little bit more of a difference because the interest rate was 10%. But again, the bigger the interest rate or the longer the amount of time, you're going to see a larger difference between those. So continuously is better. All right, so for these last two, the exact same with the other graphs that we did, all right? The only difference is when the base is E, and again, remember that's a number, 2.7-ish, right? You don't get a calculator for these. Without a calculator, there's only one value you're gonna be able to do, and that's E to the 0. Anything to the 0 power is 1. The rest of them you're not gonna be able to do. For example, what is E to the 5th without a calculator? 2.718 to the 5th power without a calculator, anybody? Do you get what I'm saying? No, you're only gonna be able to do 1 point. That's the only difference. You won't be able to get 3, you're gonna just do 1, right? So first, did this graph shift up or down? It did not. Do you guys see anything added on at the end here? No, okay. That means that your horizontal asymptote is still at 0. That's where it would be unless it shifts. This one didn't shift up or down, so it's still gonna be at 0. All right, now make an XY table, but we're only gonna be able to get 1 point. The only one you can do is E to the 0. That doesn't mean you plug in 0. In this case, what are we gonna plug in? Good, 5. It seems like you guys are really coming with me on that. That hasn't been like a issue. 5 minus 5 would be 0. E to the 0 is 1. Times a half would be a half. So the only specific point you can plot is 5 1/2. Now here's where we do run into an issue because everyone looks at me like, Ms. Cole, what on earth do I do now? There's no rest of the graph. I get that that's hard, but look, you have a 50-50 shot. The graph either increases or decreases. Do you see any kind of reflection going on for this one? No, so it's going to increase and it'll look like this. Again, I get that that's difficult without a calculator, but again, just remember you have a 50-50 shot. It's either gonna go up or go down. Pick one and go with it, because if you pick the wrong one, I can take off half a point and then give you the points for everything else. It's not gonna be like super detrimental, right? Once you have that, the rest of this should go easy. What's our domain? Everything, right? Range, you're going to sweep downwards to upwards. I don't like how this arrow is going. I'm going to fix that. What is our range going to be? Yeah, good. 0 to infinity. X-intercepts. None. There's an asymptote there. Y-intercepts. There is one. We don't have it plotted real specifically, all right? It's going to be 0, comma, whatever you get when you plug in 0. Watch, this is awesome. Some people love this, some people hate this. I think this is cool. If you plug in 0, 0 minus 5, negative 5. So it would be 1/2 e to the negative 5th. Whatever that is, I don't know what it is without a calculator. Here, let me show you. 1/2 e, which again is like 2.7, to the negative 5th, 0.003. Does that make sense that this would be like 0.003? But without a calculator, you just leave it like that, which is great. All right, is it increasing or decreasing? Increasing, decreasing will be none. and then end behavior. All right, left end is going to 0, right end to infinity. All right, we'll just try one more. How did this one get shifted, this last one? Up 3, perfect. Go up 3, dot that in, and your horizontal asymptote is y equals 3. You're only going to be able to get 1 point without a calculator. What is the only number we're going to be able to plug in this case? 0, good, perfect. When you plug in 0, you can't negative a 0, so that's just 0. E to the 0, 1 plus 3, 4, so 0, 4. Now here's where you run into a dilemma. Is it going up or is it going down? Again, you got a 50-50 shot. What do you think in this case? I heard like one of each there. Do you see a negative? Is there a reflection anywhere? There is, so it's going to be going down. It's going to go this way. But again, if that's difficult, which it is, pick one and go with it. If it's wrong, I can take off like half a point. And then as long as all this matches your graph, you'll get credit for everything else. So like, don't stress overly about that, okay? Domain will be everything. Range is what to infinity? Good, 3 to infinity. There is no x-intercept. Y-intercept is 0, 4. It came out nicely for this one, but if it didn't, again, you would just plug in 0 and whatever you get is what you get. Are we increasing or decreasing? Perfect, so decreasing is everything, increasing is none, and then your end behavior. Limit as x goes to negative infinity of the function, limit as x goes to positive infinity of the function. Where's the left end go? And the right end is 3. All right, I know you all like deflated there. I'm gonna show you exactly what the homework looks like though. Okay, so can you just pay attention? I'm gonna do one of each of the types of problems that you're gonna see, all right? I couldn't separate this. The topic is called graphing exponential and log functions. If you get one that's a logarithm, skip it. Okay, and you may just have to skip a few until you get to one that's an exponential. I can't separate that. They put them together, all right? So go until you get one that doesn't say log. Do you all understand that? Just skip them, all right? So we're gonna graph these. Asymptote, where did this graph get shifted? Up 4, it's gonna be horizontal. And then you can just take this and scoot it to 4. All right, and then you can move around the points. We want to plot a couple of points. What would you like to plug in first? Let's do 0. Anything to the 0 power is 1 times -2 would be -2 plus 4 is 2. So we get 0, 2. Now we need to do one more. I would plug in -1 because that will flip it. If we plug in -1, 1/2 to the -1 will give us what? Good, perfect. 2 times -2, -4 plus 4 is 0. So you get -1, 0, just scoot it over, submit answer, green check, all right? So move the asymptote where you want it to go, and then move the points where you want them to go. The next thing is the features. All right, and again, if a log graph comes up, just skip it. This function is exponential. Horizontal asymptote of y equals what? Where is this one at? -6. The range is -6 to infinity, and it is increasing on its domain of all reals Sorry, I got to scoot it down. The left side, as x goes to negative infinity, where's the graph going? To negative 6. And then as x goes to positive infinity, where's the graph going? Infinity. Answer, green check. All right, and then the last section, some of them don't say pert. Some of them say some other weird nonsense. Again, skip those until you get one that says pert. You're just gonna plug everything in. All right, what is the initial amount for this one? What does it say is the principal? Yeah, 81,200. E to the power, all right, what's the rate? All right, so I'm gonna write 0.036 times the number of years, 13 years. Everybody type that in your calculator. Did you get that? Now, they make you round to the nearest cent. So when it's 0.949, you have to do 0.95 or it'll mark it wrong. Okay, again, I would accept that answer and I would accept it to 3 decimal points. Okay. Oh, and you know what I just realized? I thought all of that was showing up on the video, but I forgot to hit share screen. I'll record it separately and then download that video. Sorry, guys.